The power triangle, a visual representation of AC power. Unveiling the power triangle. The power triangle is a visual tool that helps us understand the relationship between the three fundamental components of AC power: real power, P, reactive power, Q, and apparent power, S. It's a simple yet powerful concept that is essential for electrical engineers and technicians. Real power, the workhorse. Real power, often measured in watts, W, is the actual power consumed by a circuit to perform work. It's the power that lights up bulbs, heats appliances, and drives motors. Real power is dissipated as heat or converted into other forms of energy. Reactive power, the imaginary player. Reactive power, measured in volt-amperes. Reactive, var, is the power that oscillates between the source and the load in an AC circuit. It's associated with the energy stored and released by inductive and capacitive components. While it doesn't directly perform work, it's crucial for maintaining the voltage levels in the system. Apparent power, the total power. Apparent power, measured in volt-amperes, var, is the total power supplied to a circuit. It's the vector sum of real power and reactive power. Apparent power represents the total power that the circuit appears to be consuming, regardless of whether it's actually being used to do work. The Pythagorean relationship. The relationship between real power, reactive power, and apparent power can be represented by the Pythagorean theorem. S superscript 2 is equal to P superscript 2 plus Q superscript 2. This equation tells us that the square of the apparent power is equal to the sum of the squares of the real power and the reactive power. Power factor, a measure of efficiency. Power factor is a measure of how efficiently electrical power is being used. It's defined as the ratio of real power to apparent power. Power factor is equal to PS. A power factor of 1 indicates that all the power is being used to do work, while a power factor less than 1 means that some power is being wasted in the form of reactive power. Improving power factor. Low power factor can lead to increased energy costs and reduced system efficiency. To improve power factor, we can use power factor correction techniques, such as adding capacitors to the circuit. Capacitors counteract the effects of inductive loads, reducing reactive power and improving the power factor. The power triangle in action. The power triangle is a valuable tool for analyzing AC circuits. By understanding the relationship between real power, reactive power, and apparent power, we can design more efficient electrical systems and optimize energy usage. Conclusion. Whether you are a student, an engineer, or a technician, the power triangle provides a clear and concise way to visualize the complex interplay of power in AC circuits.